some of the questions that came up from the first paper talking about gravitational effects for cosmic redshift are a nice lead into this paper, because this paper will examine at least one other dissidence theory as to a gravitational explanation for the cosmic redshift. And my goal here was to see whether his theory would still apply if I had a variable light speed as opposed to a constant light speed, which is what he assumes in his analysis. So this is really a reanalysis of this dissidence theory, but relaxing the assumption of a constant light speed. Cosmic expansion by gravity. Dissident physicists have postulated various alternative explanations for the alleged cosmic expansion due to the Big-Bang-induced and dark energy-sustained ever-increasing expansion of space-time. Tired light phenomena, which I mentioned, is one of them. Bill mentioned decreases in the gravitational constant. I won't address that here, but I mean that's another family of explanations. Basically, the idea with gravitational redshift is gravity which stretches light waves and bends them via lensing. If you accept gravity, and Dr. Dowdy isn't here to talk about gravitational lensing, but there's debate as to whether that really takes place. But for the arguments here, we'll assume it does. So gravity which stretches light waves as they pass large masses, stars, galaxies, galactic clusters. This stretching phenomena is an increase in wavelength and corresponding decrease in frequency, which is required if light speed remains constant within a medium. You've got to have a medium to have a constant wave speed. And again, I'm not really getting into ether today, so we won't get any further with that. If light speed is variable, would there also be a gravitational cosmic redshift? That is, one that alters light speed without affecting the waveform itself. That is, no stretching. So can the theory that I examined here equally hold if I don't assume a constant light speed and a stretching of the waveform? Gravity plus ether, a theory. I question the need for constant light speed to explain the cosmological redshift and other alleged relativistic effects. The author, Conrad Ranzan, he proposes a quite unique explanation for the cosmic redshift. He combines both ether theory and gravitational effects, and he calls it the dynamic steady-state universe. It describes how the cosmic cell structure is intimately tied to the mechanism of an ether theory of gravity. The space medium expands, flows, and contracts, with the expansion and contraction occurring in separate regions that define and sustain the universe's cellular structure. The DSSU, dynamic steady-state universe, as a model of the real universe, is structured as cosmic cells, which include a cosmic redshift on the light traveling through them. And if you're interested, this is his website. He has a nice, detailed explanation, some of which I'll extract here to the extent I need it for what I analyze. Ranzan's concept of the DSSU. Simply, Ranzan's cells are approximated as spheres divided into regions of equally expanding and contracting space medium. Residing at the sphere's center is a galaxy cluster which causes an inflow or acceleration of the ether. This stretches a light waveform, increases the wavelength. Whether light is incoming, that is moving toward the galaxy cluster, or outgoing, moving away from the cluster within a cell. So you've got this cell, you've got this galaxy cluster in there. If light's coming in from this direction, it gets stretched out as it gets closer to the galaxy, and as it leaves, it still gets pulled back a little bit and stretched out, and the same happens no matter what direction it's coming in. Basically, the closer you are to the galactic cluster of the center, the more stretched out the waveform is. And this is a gravitational form of a redshift, and this is what Ranzan is trying to analyze. The key is a differential between the front, which is the closest part to the cluster, or more towards the center, and the back, the farthest part of the cluster of the waveform. So you've got the cluster here, you've got the waveform coming in. When you're closest to the cluster, the waveform is more stretched out than when you're farther away from the cluster. The front part always experiences the greatest acceleration due to the ether as it approaches the cluster, elongating the wavelength, thereby lowering the frequency and causing a redshift. As light traverses a cell, it is stretched throughout its passage, and light continuously reddens as it travels from its source. Of course, this stretching is a consequence of light having a constant speed, which Ranzan accepts. I mean, that's what stretches it out. This is a model of his version of the universe, the DSSU. You can see that he does have these cells. They're shown as hexagons here, but he really analyzes them as spheres. And you can see that we have light that started out here someplace, and as it starts going through, it hits the first galaxy cluster. The waveform is fairly tight. It hits the second one, stretched out a little bit more, the third one, fourth, etc. And you can see that the more galaxy clusters it passes, the more stretched out, elongated the waveform is, and that's what he believes is the gravitational redshift of light as it travels with distance. His typical galaxy cluster is based on Virgo, which is 1.2 times 10 to the 15th solar masses in size, has a radius of 7.2 million light years, and they're each located at the center of a cell that's 2 times 10 to the 8th, 200 million light years wide. Ranzan estimates an average inflow speed towards the cluster of 2 times 10 to the minus 5 kilometers per second per light year. Comparison with the most popular version of the Big Bang, I guess it's called the Lambda CDM model, yields excellent agreement. And this is, you can see that the Lambda model for expanding space redshift is shown in black dotted line, and the red line is the DSSU that Ranzan calculates. These are just taken directly from his work, so I'm just reproducing what he did here. So he gets excellent agreement with his assumptions, and so is got a plausible explanation for redshift due to gravitational effects. What I wanted to do was look at the exact same universe structure that he had, but I wanted to relax the requirement of a constant light speed. I'm neither going to try to confirm nor refute his theory, but I want to use it as a starting point to consider a purely gravitational cause, with or without ether. Again, I'm not getting into the ether portion here, for the cosmic redshift, without the constraint of constant light speed. I adopted his geometry. I didn't need to retain the cellular structure for what I did, but basically I had galaxy clusters with masses of 1.2 times 10 to the 15th solar of suns, 2 times 10 to the 8 light years apart, and I looked at 6 clusters from position 0, my starting point, where light is emitted at a speed c, and that's just the number crunching for the speed c. And I looked out over these 6 galactic clusters to a distance of 1 times 10 to the 9th light years, 1 billion light years. As soon as light is emitted, it feels a gravitational restraining force per unit mass, that is an acceleration from the emitting cluster itself. So as soon as the light comes out, the galaxy cluster from which it's emitted is trying to pull it back and start stretching the waveform, if you believe in a constant light speed. Or if you don't, it actually believe it may be slowing the speed from the first emitting cluster, and this is the formula for the gravitational redshift, and it basically comes out to be 6.64 times 10 to the minus 5 cubic kilometers per kilogram per year squared, where d is the distance from point 0 at the time t, measured in years. Simultaneously, light feels gravitational attractive forces per unit mass accelerations from each of the remaining 5 galaxy clusters. So basically, there's the emitting cluster, and then there's the other 5. So as soon as the light comes out, it's got gravity trying to pull it back from its emitting cluster, but the other 5 downstream are trying to pull it forward. And obviously, the ones farther away have less of an effect. But what I did was try to calculate using the formula for gravitational redshift on each one of these. So I looked at d sub I, which was 6 discrete distances from the emitting galaxy 1 out through number 6. The net force acceleration is the sum of these 6 forces, or accelerations. In units of 10 light years, I estimate the speed of light during each interval, v sub j, plus the net acceleration, times the time interval itself, where the initial speed, the emitting speed, is the speed of light. I then repeat this calculation over a much greater distance. Originally I did it for 1 billion light years. I then changed it to 10 billion light years. I spaced the galaxy clusters out a bit farther, and I increased their masses to 5 times what they had been. But I still use 6 composite clusters. And I wanted to see if changing scale by a factor of 10 had a significant effect on my results. And this is the results that I got. Both geometries indicate slight but steadily linear decreases in light speed over the cosmic distance. The vertical scale here is the decrease. So the increase here is actually showing greater decrease as I go, because I plotted the decreases versus distance. And so there were the two simulations. First I did 1 times 10 to the 9th light years. That was my total distance. So you can see this first set of simulations shows the decrease in light speed over 1 billion light years. And then I did the 10 billion light years, and you can see that there's still the light speed decreases as the distance increases. Again, this is a plot of the decrease in light speed, not the light speed itself. So based on my postulate that light maintains its waveform, again, I'm saying that the waveform of light itself is not affected. The speed of light is affected. And mainstream and also accept constant speed of light say the speed is unaffected, the waveform is stretched, and the frequency is inversely proportionally affected. But based on my postulate that light maintains its waveform unless refracted, and the fact that, and I've given papers in the past talking about constant light speed, variable light speed, etc. I end up indicating that a cosmic redshift due solely to gravity, yes. So with a variable light speed, I still find that gravity can be an explanation for the cosmic redshift. So I have a constant waveform, that is an invariant wavelength. Any change in speed must be manifested by a change in frequency, because if lambda c equals nu times lambda, if lambda's constant and c goes down, then it's nu, the frequency that's going down, because the light speed's going down. That will lower the frequency just as much as a stretching of the waveform would lower the frequency. Therefore, as light speed slows, frequency decreases and light reddens. So basically I'm saying that I'm taking RANZAN'S model, and the only change I'm making is that I'm assuming a variable light speed versus a constant light speed. I get consistent results that there can be an explanation of gravity as being a cause of the cosmological redshift. The gravitational redshift can be quite significant for massive, this is RANZAN'S conclusions. The gravitational redshift can be quite significant for massive, dense, compact stars or star-like objects. For ordinary stars, as well as extended, more tenuous structures, it's surprisingly weak. A photon emitted from the sun's surface acquires a small redshift of only 2.1 parts per million. A photon from the nominal surface of an entire galaxy cluster, such as the Virgo cluster, will accumulate an astonishingly small redshift of only 2.5 parts per million, assuming, of course, that the general relativity effect is the only one in play. Again, he doesn't reject relativity in his theory. Evidently, the gravitational mechanism is far, far too weak to serve as a realistic explanation for the cosmic redshift. So as a result of all his efforts, while he says that, yes, there will be a redshift due to gravity on the cosmological scale, the magnitude of it that he calculates is far too small to equate with the measured redshifts that we see. I get a similar result, although under mine, I get, my redshift is several orders of magnitude greater than RANZAN'S. Again, he was getting only 2.1 parts per million. I was getting more like, this is one part per thousand. So I'm kind of like a factor of 1,000 higher than him, but it's still small. So I can say that my conclusions are similar to RANZAN'S. I came up with a stronger gravitational effect, but still not nearly high enough for it to alone be an explanation for the cosmological redshift. Current physics cites waveform stretching as the effect of gravity that would cause the cosmic redshift, upholding the assumption that light speed is constant within a medium. Using the geometry from RANZAN'S theory of a cellular structure to the universe with accelerating ether, I attempt to show that a gravitationally based cosmic redshift is possible without the constraint of constant light speed. My results show such a redshift several orders of magnitude greater than RANZAN'S, but it's still small and unlikely to be the sole explanation for the cosmic redshift. Nonetheless, it demonstrates that the constraint of constant light speed within a medium need not be applied to explain at least one of the alleged causes of the cosmic redshift. That concludes this talk.
Questions for him?
Musa has a question.
Yes. Yes. Some people ascribe the redshift to the decrease in the speed of light as it passes through the Earth's atmosphere due to refraction. What do you see?
Well, that's how, I don't know if you've heard Dr. Dowdy's talks at some of the earlier conferences, but he uses that exact same explanation for what's alleged to be gravitational lensing. He says that actually what's happening, and I guess he worked in the mainstream for a long time. I think he worked with NASA or for NASA and actually did a lot of these studies. And what he shows is that if you have true gravitational lensing, there should be proportionality in the degree of lensing with distance from the surface of a star or very dense mass object. So it shouldn't, the gravitational lensing, while it would be strongest as for the light rays passing closest to the object, there would still be some degree of lensing, a decreasing degree as you go farther out. What he's found is that there's lensing up to maybe 1 or 2 radial multiples from the center of the star mass or whatever, and then it's gone. And so his contention is that what we're really seeing when mainstream claims gravitational lensing, yet another proof of relativity, is refraction going through some sort of atmosphere around either a star itself, a galaxy itself, some sort of corona or halo. And it's not gravitational lensing, but it's refraction, because when you get out to 3 or 4 radii from there, it goes to 0 instead of just going down proportionally. And he's had some really good demonstrations in some of the earlier conferences showing how this aligns with a lot of the observations he made. So I agree that refraction should be an explanation for a lot of this. Bill?
Just go ahead. Halton Arp, in his experiments or observations, found connected galaxies with different redshifts. And they were not just a small difference, a huge difference. And can your work give any explanation for that?
I have a paper where I looked at the discretization of redshift based on the work of Halton Arp and some others that work with him. And while I don't address it here, I do have a paper on that where I looked at why it might be discrete, etc. And I know his theory is that quasars are not galaxies born 10 billion years ago, but they're young ejecta from existing galaxies, because statistically there's just too many quasars located close to galaxies for that to be coincidental. And the fact that when they're closer to the galaxy, they have the higher redshift, maybe because he believes in an intrinsic redshift combination as well as possibly an effect due to the ejecta speed of these proto-galaxies. But he believes there's an intrinsic redshift. And I'm trying to remember the paper I did, but I think he believes that there's some changes in the size or the effect of the matter itself. But his theory is that quasars, etc., are not very young galaxies from 10 billion years ago. They're just ejecta from existing galaxies, and they're ejected with high redshifts, and as they move farther out, they grow in size to become their own galaxies, the redshift decreases. And again, the statistics show that too many of these quasars are located too close to too many existing galaxies for it to be coincidental. And I say I have a paper on that, which is in the future, where I address that.
Well, in his work, he shows that the quasars have a redshift that's 100 times larger than the redshift of the rest of the galaxy. So the question is, what makes it so big?
And again, I think it's not speed. I think he believes that there's an intrinsic redshift that may be pulling the light back or something like that. I'd have to look again to see exactly, to refresh myself on his work.
I don't think he actually knows what the source is. He's
Yeah.
just pointing out the data.
And he lost all his astronomy, all his telescope time after he came up with that theory. Yes?
My question deals with the variable speed of light.
Mhm.
Are you aware that there are a number of Are you aware that there are a number of mainstream physicists who are playing with that concept?
I haven't seen very much in the mainstream with variable speed of light, except I know they've talked about slowing the speed of light as you go through different media, but I'm not talking about light being slower in a diamond than it is in a vacuum.
I mean, there's Joel Maguejo of the Imperial College of Science and Technology in London. He's written a book on that very concept that was given favorably reviewed in the Scientific American a few years ago and was published, and in other scientific journals. And I think there's also an Anthony Valentini in Canada also deals with variable speed of light. And if I'm not mistaken, the Nobel Prize winner Sheldon Glashow has his own alternative to special relativity, which also deals with variability of speed of light.
And they're being accepted in the mainstream.
Well, they haven't lost their jobs or anything.
Yeah, no, that's
In fact, I was going to.
that's a bit surprising.
Well, in fact, I was going to give Dave afterwards some material on Valentini because I guess I don't know whether these guys know or not, but they could be servers are Trojan horse within the establishment, so to speak.
Yeah, I mean, that is surprising that they must have very good pre-existing reputations in order to come along, to still be getting published there. But like Halton Arp, who was well respected as an astronomer, as soon as he started going against the mainstream thought, quasars are vast distance. I mean, first they take away your telescope time, eventually they put you in a broom closet. That was it for him.
Any more questions?
Yes, please. Yes.
Talk close into the
Has the redshift been measured with respect to the other planets, other bodies on the Earth?
Not that I know of. I mean, all our redshift measurements either come right from the surface of the Earth, or I guess the Hubble telescope has measured redshifts, but I don't think we've even put something on the moon that could measure. I don't think any of the satellites we've sent out have attempted to measure redshifts. I think only the Hubble telescope has probably done some measurements, but I think that's about as far away from the Earth as we've gotten for redshift measurements.
Any other questions? Okay, thank you very much.